Hello everyone, welcome to the 6th video tutorial for Intel Galileo Gen 1 development board. In the 5th video, we saw how to create a HTTP server on Galileo and also start controlling a blinking of an onboard LED through a web page hosted on Galileo. In this video, we will see how to auto-start an application immediately on boot up. Later in this video, we will also see how to auto-log in Galileo every time it is connected through serial terminal. In this part of the tutorial, we will create a setup using systemd, which will give same impression as sketch.elf. This is an alternative method to persistent sketches created by Arduino. Persistent sketches are the sketch.elf files dumped inside /sketch folder on the Galileo when an Arduino program is downloaded on the board. Persistent sketches, as the name suggests, are the applications which are not lost on powering off the board. Systemd is designed for Linux and programmed exclusively for Linux API. Systemd is a suite of system management daemons, libraries, and utilities designed as a central management and configuration platform for the Linux computer operating system. Systemd is pre-installed in the Linux image available on the Intel Download Center. Systemd folder can be found on /etc folder on the board. For the purpose of this demo, I will try to create setup to auto-start our application discussed in the 5th video tutorial, which was a Python script to host a web server on Galileo and control of blinking of an onboard LED through web page. First, we will change the directory to /etc/systemd/system. Then we will open a new file. Let's call it web_led_blinking.service. We can give any name to our file. We will make sure the extension of this file is .service. Next, we will follow the syntax of systemd service files and make a .service file for our application. There are 3 parts in this service file. First part is categorized by unit. In this part of the file, we will provide a descriptive name to our service file. If we have any constraints as to when we should start the service file while booting up, we can provide this additional list of constraints in this part. Like in our application, it is required that we execute Python script only once we have the internet connection up. So, the line after is equal to network.target will make sure that our application service file is executed only once we have the internet connection up. The next part, categorized by service, is where we would describe the part of our application code. We can also set the working directory of our service. For example, to run our application, in addition to the Python script, we also need to provide an HTML file which will serve as our web page. Since there can be dependencies on more than one such files, we have a way of specifying a directory where we can keep all the files required to successfully run our application. So we will write working directory is equal to /home/root, and then exec start is equal to /home/root/blink_led_web.py. Here in exec start, we will specify the command to run our application as we would write on the command shell. In our case, since we do not have any arguments, we will just specify name of the script to run. Next part is install, where we will specify the target which executes our service files. All the service files during bootup are divided into different categories like basic, network, multi-user, etc. Mostly all the user applications are served by multi-user.target. So we will write wanted by is equal to multi-user.target. We will now save and close the file. Before starting the service, we will first have to make a little tweak in our earlier Python script to dynamically grab the IP address of Galileo. Initially, we had manually entered the IP address. I will add 2 lines to the previous Python script. First one is to import module named commands, and then writing a shell command to grab the IP address from ifconfig. We will then use this IP address while creating HTTP server. Please note that you can apply any method to obtain an IP address on the fly using Python script. Next, we will use systemctl. Systemctl is one of the core components provided by systemd. Systemctl is used to control the state of the systemd services. So, we will type systemctl enable web_led_blinking.service. This will enable our service file. Then we will type systemctl start web_led_blinking.service. When I type systemctl status followed by web_led_blinking.service, it shows status as running in green. To learn more about systemctl options, please follow the link given on the screen. We can also see the onboard LED is blinking since the blink was equal to true by default in our Python script. When I now open a new browser and type IP address port name followed by / then blink.html, I can see the same web page as seen in the 5th tutorial video. When I now click stop blinking, the LED will turn off. And then when I hit start blinking, the LED will turn on. In the next part of this video tutorial, we will see how to auto login in Galileo. Whenever Galileo is connected to the serial terminal, we first have to log in order to start using the shell. To avoid this, we can simply make a minor change in the service file that calls the terminal. We will open a file named serial-get_ty at tty_s0.service present under /etc/systemd/get_ty.target.wants. If the file does not exist, we will copy file named get_ty at tty_s0.service present under /etc/systemd/system/get_ty.target.wants to the file named serial-get_ty@tty_s0.service under the same directory. We will search for the word execstart in the serial-get_ty at tty_s0.service file and then append this line with -a followed by space and the username of the board. By default, username is root for the Linux images discussed previously in the video tutorials. We will now save and close this file and then reboot. Once Galileo is rebooted, we see that it has automatically logged in. We can also see in the DMESG that our web LED blinking service has been executed. So this ends the demo on using systemd to auto start an application on boot up. Thank you for watching this video. I hope you enjoyed it.